Nice. Okay. Hello from the 403 to the HAZ. Mr. Nelson here. How are you? Finishing, I guess, just our introduction to trigonometry for pre-cal 12, working with radian degrees in our unit circle. So in the first two videos, we just introduced how we convert between radians and degrees. We started talking about points on the unit circle. So any point on the unit circle should follow Pythagorean theorem, where x coordinate plus y coordinate should, x coordinate, y coordinate, this is point xy. When I square those two coordinates, it should equal to 1 squared, right? Because that's what would make it, my hypotenuse is 1 for a unit circle. And so the last video we were just talking about kind of solving for different unknowns around points on the circle. This video, we're going to start talking about some important points on the circle. Obviously, the first 4 important points are x, y, right, where this is going to be a 0 y coordinate, but a full 1, right, because the radius is 1. So we are going to start looking at 3 additional important reference angles: 30 degrees, 45 degrees, and 60 degrees. And these are really going to be what we're going to focus on here. Okay, so let's start talking about the 40 degree mark, the 45 degrees. So 45 degrees splits this arc from here to here in half, okay? And we know that this point at 45 degrees is the same as pi over 4. Now, how do we know that? Well, we can use this. So 45 degrees times pi over 180 will give me that angle in radians. 45 over 180 is a quarter. 45 over 180 is the same as a quarter, because 45 times 2 is 90, times 2 is 180. So this is pi over 4. So this point, 45 degrees, is the same as pi over 4 in radians. And I know that this point has coordinates of 1 over root 2 for x and 1 over root 2 for y. The x and the y coordinates at 45 degrees are the same. So knowing that, I know that every 45 degrees in each quadrant will have some deviation from that, or it'll be some based on this. So here, I don't know I'm not going to figure out what this point should be, but we'll get there. But I know that this point, which we'll figure out, has coordinates 1 over root 2 for y. Y is still positive, but in this case, my x is going to be negative this coordinate. So it's going to be negative 1 over root 2, 1 over root 2. And we kind of have to memorize these, kind of, sort of. There's not a whole lot to remember. Okay? And I can figure out what angle this corresponds to by using what I know here, here, here. So I know that at this point, I'm going to be dealing with a reference angle of pi over 4, right? This line from my x-axis is pi over 4 as an angle. It's the same as it is here. But as an angle in standard position, this occurs at essentially pi here, 180 minus 45, or pi minus pi over 4. Pi over 4 is 45 degrees, pi is 180. So I can go pi minus pi over 4 is the same as, now I have to have a common denominator, so 4 pi over 4, that's how I can rewrite pi, because those will actually cancel, minus pi over 4 is 4 pi minus pi is 3 pi over 4. Now I could have, if I wanted to just deal with degrees and then convert it after, I could have said, okay, 180 degrees from is where this is, minus that reference angle of 45 degrees, gives me 135 degrees. And then I could multiply 135 times pi over 180, 135 pi over 180. And then this would work out, if I simplified, divided everything by 45, I'd get 3 pi over 4. Two ways of doing the same thing. Okay, and if I use that same law, so this is 3 pi over 4. And I can use the same logic, so if I wanted to figure out this, so if this is the same 45-degree reference angle here, so if this is a reference angle of pi over 4, 45 degrees, this point, it's going to have the same magnitude, but the signs might be different. Now I'm in the negative quadrant for x and the negative quadrant for y. So my coordinate here is going to be negative 1 over root 2, negative 1 over root 2 for y. And this point, I can figure out it's going to be now pi plus a pi over 4 to get to there. Pi plus pi over 4 is the same as 4 pi over 4 plus pi over 4. So I have common denominator, and I get 5 pi over 4. I could have also done it in degrees and then converted after. 5 pi over 4. And then again here, I'm going to have a point, an angle, and it's going to have coordinates positive that, 1 over root 2 for x, and negative 1 over root 2 for y, because now we're in the negative y coordinate quadrant. And this point, again, my reference angle here is going to be pi over 4, or 45 degrees. And so this is the same as 2 pi, one full rotation is 2 pi. So I can subtract pi over 4 from 2 pi to get what this total measurement is, right? From here, this is my angle in standard position, going this way. And that's going to give me what this angle is. 2 pi as a fraction out of 4 is 8 pi over 4 minus pi over 4 is 7 pi over 4. So this will be 7 pi over 4 angle. Okay, so that's one important angle around the circle. It's 45 degrees. The other two are pi over 6, which is my 30 degrees. See, and that's going to show up everywhere else on the circle as well. And this has coordinates of, now when I'm over here, I have a really big x coordinate and a fairly small y. And that's how I can remember it. So it's going to be root 3 over 2 and 1 over 2. My x is bigger than my y. Root 3 is bigger than 1. Okay? And then up here, this represents an angle of 60 degrees. Actually, it's probably a lot more right there, but. So this point here is pi over 3, or 60 degrees. If I use my conversion, I'd find that 60 degrees is the same as pi over 3. And now it happens with a really big y coordinate and a fairly small x. And it basically is just the opposite of this. So my x is going to be 1/2, and my y is going to be root 3 over 2. Now, I can use the exact same logic I used to figure out the other points for each of these identities around my circle. And maybe that's something you should practice. But let's try, just for fun, let's do one of them, okay? So let's say it said, okay, I want you to figure out what this angle represents and what its coordinates are, okay? For right here. And I know that this is going to be the equivalent of 60 degrees from the x-axis, or it's going to be pi over 3 from this x-axis. Excuse me. So this point happens at pi plus 60 degrees to get down to here, or plus pi over 3. So let's figure out first what that angle is. Pi plus pi over 3, which is my reference angle. This would be pi over 3. So pi plus pi over 3 is the same as 3 pi over 3 if I use the common denominator, plus pi over 3. And that gives me 4 pi over 3. So this angle is going to be angle 4 pi over 3. And its coordinates are going to be, because it's a pi over 3 angle, it's a 60-degree reference angle, it's going to have some variation of this. It's just the signs that we have to figure out. So we're in the negative x, negative y quadrant, so it's just going to be negative 1/2 for the x, which makes sense because I have a pretty small x component here and a pretty big y. And then it's going to be positive, it's going to be also negative 3 over 2 for my y coordinate. That's it. So I don't want to do too much of this for you because I want to leave some of it for you to explore and try on your own. And hopefully this is enough to get you going. But basically these are the 3 important identities on the circle, and they occur in each quadrant. So all of these are the only coordinates we're really going to have to memorize, and then it's just fixing the signs based on where they are. I'm doing my best, guys.